Welcome back. I'm Rob Lang and this is my co-op exploration game Clomper. At the end of last week I finished the grabber, and then at the end of any new feature I do a regression test and I do performance work, and that's what this video is going to be about. So a regression test is where you go back through all the features in your game and you make sure that your new feature hasn't broken anything. Now the way that I do that is I do it in Trello here. I have my Trello board and I have this card that's set up as a template. And inside here you can see all the features in the game and all the different parts of those features. And what I do is when I want to start a regression test, I create a card from the template. I'm just going to call it number 1 for fun, and now I can go through each of these things and make sure they still work. So for example, for pipes I should be able to create pipes, and I should be able to delete pipes, and I should be able to rotate pipes, and let's give that a go. Let's hope it's not broken. No, that looks good, that's all rotating, and I can't place them in collision. Fantastic. And I've got a valve that can turn. Excellent. So that's all of my pipe checks. So I can come in here, I can click those all off, and they're done. And that is regression testing in a nutshell. If you find a bug while you are regression testing, that's no problem. Just log it, make a list of your bugs either in your Trello board or somewhere else, and then if you are stuck by a bug and you can't go any further, then I recommend stopping, fixing the bug, and then picking up your regression testing where you left off, so that you're not going backwards and forwards all the time. Then at the end of the regression testing you'll have a big old list of bugs to fix, and then you can finish up with that. So that's regression testing. Took me about an hour and a half. So for performance, the main aim is to get your game running as fast as possible on the target platform. Now my target platform is PC, so the thing that I'm looking at is frames per second. Now, I'm not an expert in this or these tools, so you'll have to forgive me if I get things wrong, but I've just kind of taught myself and I think I understand what's going on. I have plenty of experience when performance profiling for the web, and it's similar in a way-ish, sort of. So, performance profiling, where do you start? Now, the first thing you should start with is setting up your game in a way that represents your game actually being played. Now, I could performance profile the scene like this, which would be alright, but it's not really how the game is played. So let's stick some pipes in. Now I could start just sticking some pipes down, but that would be laborious and boring. So what I've done is I've put in a console command that allows me to just load a standard set of pipes up. So if I come in here and I go load pipe, and if I do perf profile 1, it will then load up a standard set of pipes, and this is now the frame that I will be using to do debugging. And no matter when my performance profiling goes on, I'm going to be looking at this frame. So the first place that we start is up here in the stats. So the stats window right here, you just click on that button, off we go, and we can see loads of stats here. Now I've not got any audio in the game, so we can ignore that for the moment, but my graphics are running at 25 frames per second in the editor. Now the editor will put some load on your game, it will make it slower, however it should be higher than that surely. I mean, come on, this is low poly and my PC will run games like GTA 5 really well, so I must be doing something a bit dirty and wrong here. You can see the number of batches I've got here and SetPass calls, and these are the two things that are most important. We don't really care about the others, those are the two ones that are most important. SetPass, as I understand it, is the number of times that the GPU needs to change what's material, shader and parameters so that it can draw something. So it's sort of, this is like saying, right GPU, stop yourself, you now need to change your stuff. Batches, however, are how well Unity has managed to group together your objects and then pass them off to the graphics card. And as I understand, that's quite a high number as well. So we're looking to minimize these two. If we get these two down, then we should be able to get these frames per second up and this CPU time here down. That's a good starting point, but it's not showing us anything that we can actually go away and do things with. So let's go up to Window, down to Analysis, and then open up the Profiler. And we can see we have these cool graphs. I'm just going to dock this down here to make life a bit easier, and I'm going to increase that up. It won't make too much effect on there. So you can see we've got all these graphs going along here, and we've got a green bit and a blue bit, and then there's a tiny orange bit, and then there's all these spikes. So the green bit is how much work the CPU is doing, because this is a CPU graph, on telling the GPU what to do. The blue bit are scripts, and they're usually within your control, and then the orange bit is physics and animation, and all the other bits and pieces are down there. And you can see the spikes are the garbage collector, which is in brown, and we're going to be coming back to that in a moment. Now, to analyze this, you can do it while it's running, but I found that quite hard, so I like to pause the game, which will probably make it fall over because I have a multiplayer aspect to it, and that's going to time out. But we're going to pause it for the moment. I'm going to select one of these spikes here. So you can see this spike has 17 milliseconds on the green bit, 20 milliseconds on the blue bit, and then it's got 11 milliseconds on this brown spike, and all the others are tiny. We don't really care. There are more graphs down here, but I've barely used those, to be honest, so I'm mostly going to be concentrating on these two. So let's look down here at the bottom. Now we've found one of our peaks, let's find out exactly what is going on here. So I've got a player loop, I've got an editor loop, and I've got the editor stats collection. The editor loop is what the editor is doing, so the fact that I'm running inside the editor, that means that it's going to take some processing, but only a tiny amount. And then the collection of stats measuring something actually does affect the thing you're measuring, so that is that one at the bottom, but I can ignore those two. Let's look at these two in particular. So we've got these two large bits. What we're looking at here are the totals. We've got the whole lot is 91.9, and then it's broken up 38.6, 34.1. So these are the two biggest chunks, and we've got some other bits down here, but we're going to look at these two first. So this top one is the rendering, and you see it's highlighted how much that is there. So this is all to do with the rendering, and this bit here is scripts. So this is part of our scripts piece. So what we can do is we can drill down by opening up these bits and find out what is costing us so much. And you can see in here we've got map.fixedUpdate. Well, all of a sudden this is a method that's actually one of mine. Map is one of my classes, and you can see inside map it's doing some kind of garbage collection. So let's pop over to our map class and find out what this is all about. Here we are inside the map class. Now this is one of mine, and it's the one that Unity told us was slow, and in particular it was the fixed update method. Now this update method is called as part of the Unity physics engine, which isn't every frame, but it's many of them, so it's a good one to make sure that you make fast. Anything with update on the end is definitely going to be a place where you have to make sure that performance is good. So we're looking for anywhere where there is an object created or looked up or released back to the garbage collector. So these two here, these are just booleans, that's checking some value types, so that's super fast. Let's pop into this first method. So this sets the height of each of the hexes on the map. And the first thing it does is come into this loop. Now these loops are a smell, so if you see a loop then think that might be a problem, but in this case each of these regions have already been assigned. They're assigned in the awake method, so it's not that. This piece here is just a wrap around some logic, so it's not that one. GetRay returns a struct. Ray is a struct, so that's super fast, and as is the raycast hit, that's also a struct. So these things are all pretty fast. There's a float, that's a value type, so nothing weird going on here. So let's pop into set region color. This method here, the first thing it does is, it goes and gets component, mesh renderer, and mesh renderer is an object. So it will set the mesh renderer, and at the end of this method, this variable goes out of scope and the garbage collector will collect it. So that's quite slow. Now what I can do to improve that is save this somehow by making it a property of the class. I'm not going to do that one though, because there's another one coming up. So there we go, we found out the set region color has a slow piece in it that I'm going to have to fix, and then we come down to this physics raycast. Now this is pretty quick, that's a quick line, that's not really doing anything expensive, but this bit here, it's another GetComponent, that's a bit nasty. And I'm going to show you how I'm going to fix this one. So what I'm trying to do with this line is I'm asking it, is the thing that it's hit a quest? is it of type quest? And there's another way that I can do that. I can say var is quest, and rather than actually creating a new object here, what I can do is I can say hit transform tag and make sure the tag is a type quest. Now I've already tagged that object, so I know that that's correct. I can then say that this is the quest. On the occasion that it is a quest, which isn't very often, if this is running thousands of times, a quest will only be hit once or twice when a quest is within range. And then we can say is quest. So if it is one, then we can get hold of this quest and say, can this quest be completed? And then we're back into set region color. Now this is not so bad because this is not going to be run every time. It's going to be running 5 times maybe every other frame when you're close to a quest. So it's not an enormous amount of load. And then we keep going. And we can keep doing the same thing if we pop into find height map. This is actually pretty fast. There's only a bunch of comparisons between value types, and that's a value type set as well. And then finally we do some lerping, which is pretty quick, and then setting of scales and positions. So generally speaking, the rest of this is pretty fast. The get component, there may be a way to make that faster, but for now that will improve this method a lot. Let's get back to Unity. So here we are back in Unity. Now I haven't made those code changes yet because what I want to do is take a baseline. Now a baseline is a snapshot of where you were before you started any performance improvements. So you take that snapshot in time before you do any code changes, before you change shaders or anything like that, take a snapshot. And Unity has a cool tool to do that. As you can see here, we want to capture a reasonable frame. So we're just going to wait for this frame to just calm down so it looks like it's repeating. There you go, that looks pretty good. And we're going to stop Unity there. Lovely. And it's going to keep hold of that information. Then what we're going to do is we're going to go and get a new package that you might or might not already have. It's called the Profile Analyzer. You can go and download it. It's free. It's in preview, but it works pretty well. There are lots of videos of this online. There's one particularly good from Unite Copenhagen 2019 on this one. So once you've done that, you will find you'll have analysis and then Profile Analyzer here at the bottom. So we're going to load this one up, and it's a big old window. So I'm just going to make sure it's sized so that YouTube can see it. Lovely. Okay, so now what we're going to do is we're going to pull the data out of the main window. So that is, it's going to pull the window now. You know what, those graphs that you saw before? It's grabbing all of that and it's doing some analysis. Boff, there you go. And it's showing us much the same stuff. It's telling us all the things that are really costly, and we'll find map down here if we looked into enough detail. But we're not going to do that for the moment. What we're going to do is we're going to save this, and we're going to call it something like perf profile. This is our baseline. Fantastic. And we can come back to that later, and we can compare it later on using the compare window. And I'm going to do that a bit later. So before we go any further, let's look at how well our garbage collection work has done. Now we've got a nice stable frame here, so we're going to go up to Window, Analysis, Profile Analyzer, and rather than going on a single tab, we're going to compare with our baseline from earlier. So in the orange data track, we are going to pull the data from the main game, and then in a moment we will load the data of our baseline into a blue data track to allow this tool to compare. And the comparison is where this tool really comes into its own. So here we go, I've loaded up the baseline, it's just coming in now, and here you go. So now we can see on the blue side, which was our baseline, it was doing all of this work for garbage collection. And you can see that the two most expensive methods, which were the map fixed update that you saw me fix before, and also this pipe UI update, which you didn't see me fix but was pretty much the same sort of problem. That was setting UI elements in that one. They were both costly, and they were turning this GC collect into quite a large lump, whereas in the new post changes we've got nothing. You know, they're tiny amounts, so the difference is all of it. So that's great. That's what you want. You want to see your baseline being costly and your up-to-date game not being costly. And that's how well we did. So here we are back in Unity. So you can see now down here in the profiler that all the garbage collection spikes are gone. There's the odd 1 or 2 spikes, but generally we got quite a steady frame rate, and that's what you want. Unfortunately, our steady frame rate is about 30 frames a second, and that would have been great in 1994, but we want to be going for 60 frames a second. Now there's some more work to do in the scripts down here, but I'm more interested by this big green chunk, because I'm not actually making the renderer do a lot of work. So let's see how I might be able to reduce that. And the way we're going to do it is by using the frame debugger. So let's go up to Window, down to Analysis, Frame Debugger. Fantastic. Now when we enable this, it is going to pause the game and grab one frame. And this is a little bit like magic. So I'm going to move this down here. Oh, here we go. So it might make the game crash a little bit because of the multiplayer aspect. So let's go to enable. There we go. So it's freeze this frame. That's good. I'm glad. And then what we can do is we can use this slider at the top here to see all the different layers. So I'm going to move it all the way back to the bottom. And then I'm going to move it ever so slowly. So it's doing some rendering. Lots of work. Rendering. That's interesting. I wonder what that is. What could that be? Lots of work. Lots of work. Lots of work. Still loads and loads of work. Why is it doing all this work? Lots of work. Lots of work. Haven't got to the pipes yet. Lots of work. Okay. Lots of work. Still loads of work. Loads and loads and loads of work. Ah, here we go. Here's our scene all of a sudden. Well, that's great. There we go. And now it's building up our scene. And then finally it starts looking like what we might expect. Fantastic. But it spent half of the time working on this. And this here is a downwards camera for the scrap grabber that I was working on. So all of that work there was the downwards camera. Well, why is it doing so much work for that one camera when all it's really doing is rendering something that looks a bit like that? That's an enormous amount of work. That doesn't make sense at all. So then I thought, well, hang on a minute, is this camera actually rendering a lot more than it should do? So let's bring it back to here. So I went to this and then I came into the proxy. Now our scene, if we just look at our scene for a second, I'm just going to show you behind the curtain for those who've not seen it. This is the bit that you're running around in. There's the Clomper. And then if I come up and I go up, 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 here's the actual real world. And here's the proxy of the Clomper. The grabber here has its own camera. And that camera is on a layer here. So let's have a look at this camera a little bit more. And I came down here and I realized that its culling mask is everything, which means this camera to render is not only rendering just this floor bit of the environment, but it's also trying to render all of this as well. So it renders all of this and then it puts this ground layer in front of it rather than just to these layers. So if I slick that to nothing, and if I go to env and env proxy, then all of a sudden it's only rendering the things in the environment. And these are layers that I've set up to group my objects by things out in the real world and then things down inside the Clomper, which is all the other layers. So that was an enormous jump at that point. I got quite a lot of performance out of that. But while I was here, I wanted to do some more work. So let's go back into the game window here, and I want to know why the pipes were actually being rendered in a slightly odd way. So if I come back to here, now you can see that this pipe here has been rendered on its own, and then you get these two that are rendered, and if we keep stepping through, then you get these ones over here, and then those pieces there, but not the ends of the pipe. And so it goes, oh, then it's got the ends of the pipe, fantastic. And then it keeps going, and then it does the middle bits of the pipe, and then it does the end bits of the pipe. It seemed really weird to me that it was grouping them in quite that way. So it's grouping them together. So I went and did some reading, and I found that one of the reasons that it's grouping them together like this is that the way I set up my pipes. So let's pop into a pipe and have a look. So let me go and get the straight pipe here. Let's pop back into scene, and this is what a pipe looks like, just in case you've not seen one. I'm not sure how you'd be able to watch these videos and not see a pipe, but there we go. And I've got all my bits and pieces to do them. I've got my colliders, I've got triggers, I've got most of the gizmos switched off at the moment. But the most important thing down here is in the mesh. And you can see I've got 1, 2, 3 different materials rendering on this object. Well, that means that just to render this one pipe, it's going to need to do things 3 or more times, depending on whether it's in light or shadow. So it has to do all of that work. And then these materials, each one of these materials has a different shader behind it. And that was making it even worse. So if I come into the pipes here and I have a look at the materials, there's the inner pipe. That's using the standard pipe, inner pipe. And then the valve handle doesn't count, and then I've got some shared ones down here, and I've got the HDR highlight, that's using metallic highlight. So Unity wants to group things together as best it can so that it can do only one of these SRP batches, which is one call to the graphics card. Each one of these things here is a call to the graphics card. As you see, it's building up the scene. And it needs to do as few of those as possible, because this is the most expensive bit that it does, and we have some control over that by trying to use, rather than all of these different materials here, we're using all these materials and all of these shaders. I'm now going to try and move to one shader and one material, and I think it's possible. I'm still playing with that. That's for next week. But that's the next thing to do, to try and reduce the number of these calls, because there's a hell of a lot of calls in here and we need to really reduce these down. So that's pretty much all I know about performance and regression testing. Now I hope this long video has been useful to you. Let me know down in the comments if it has, and if you like the video, hit the thumbs up, and if you want to see some more, then please hit subscribe. Thanks for watching.